This is example 1-10, a viscosity measurement. So we are using a rotational viscometer to measure the viscosity of a liquid. The viscometer has the following. This is example 1-10, viscosity measurement. We are using a rotational viscometer to measure the viscosity of a liquid. The viscometer has the following dimensions: an inner radius of 4.9 centimeters, an outer radius of 5 centimeters, a height of 10 centimeters. We set the viscometer to an angular velocity of omega is equal to 0.5 per second, and we measure a moment of 5 times 10 to the minus 5 Newton meters. So that is then the viscosity of the liquid. Now we have our equation. So mu is equal to m times r outer minus r inner divided by 2 pi r inner squared times r outer times omega times h. So that is what then? That is 5 times 10 to the minus 5 Newton times meter. And then the outer radius is 5 centimeters. So 5 centimeters minus 4.9 centimeters divided by 2 pi times the inner one is 4.9 centimeters squared. Outer was 5 centimeters. Omega was 0.51 over seconds. And the height was 10 centimeters. All right, so let's convert these all to regular units. So we have 5 times 10 to the minus 5 Newton times meters, and that is 0.05 meters minus 0.049 meters divided by 2 pi 0.049 meters, that's squared, 0.05 meters, 0.51 over seconds, 0.1 meters. Excellent. Now we can stick that into a calculator. We get 0.00132574. And what do we get for units? We get a Newton up here. We get meters and meters, so meter squared. Then we get squared meters, cubic meters, meters to the fourth. And we get 1 per second, so second goes up here. I think that's all the units that we have. So of course meters cancel out, and all of this to the front here we can say is 1.3. That's a 5, but that's even, so that stays. So 2 times 10 to the minus 3. And then the units are Newton times second divided by meter to the fourth, meter squared, so meter squared, which is of course the unit that we want to get for a viscosity. So this was a quick way of calculating the viscosity based on a measurement in a viscometer, in a rotational viscometer.